Section 9.1, Inverse Variation. In a previous chapter, we discussed direct variation. There was a general formula for y equals kx, where k cannot equal 0, and we know k is the constant of variation. In that situation, as x increased, y would increase, or if x decreased, y would decrease. In this section, we want to discuss inverse variations. The general formula for that is yx equals k, or we can convert that to y equals k over x, or x equals k over y with simple algebra. Again, k cannot equal 0, and still k is the constant of variation. In this case, as x increases, y will decrease, or if x decreases, y will increase. Let's take a look at an example. How much time is needed to drive to Pittsburgh 100 miles away? Here I've created a rate and time chart. As you can see, if I drive at a rate of 30 miles per hour, it takes me 3 1/3 hours. If I plot that all the way to 80 miles per hour, which takes me 1 1/4 hours, I have a chart that shows as my rate increases, my time to my destination decreases. Therefore, this is an inverse variation. Something to note on inverse variation is if you double the x values, you will then divide your y values by 2, or your y values will be halved. For example, at 30 miles per hour, it takes me 3 1/3 hours to get to Pittsburgh. But if I double x, which is 60, it will take half that amount of time. Instead of 3 1/3, it'll take me 1 2/3. If I look at 40 miles per hour, it takes me 2.5 hours to get to Pittsburgh. If I double 40 to 80, it doesn't take me 2.5 hours. It only takes me half that, which is 1.25. Let's take a look at another example. Here, suppose that x and y vary inversely. Write a function that models each inverse variation. Here I'm given x equals a -7 when y equals 3. We know our general formula is y equals kx, and x and y vary inversely. We want to follow these procedures to determine this solution. First, I want to substitute the given values of x and y. So I'm given a 3 for y equals k over x I know to be a -7. Now it says find k. I can do that by multiplying by a -7 on both sides, and k will be a -21. Now I want to use the value of k to rewrite the function. Therefore, y equals k, which I know is a -21, over x. I want to follow the same procedure on my second example. Here I have y equals k over x, and my given values of x and y are 12 and -4. Substituting the given values, I have y equals a -4 equals k over x, which is 12. I want to find k, so when I solve, I multiply by 12 on both sides. That gives me k equal to a -48. And when I substitute back in, y equals k, which is a -48, over x. In this example, I want to determine is the relationship between the values in each table a direct variation. In this case, my x values would increase and my y values would increase, and each ordered paired ratio of y over x would have the same constant of variation, or same value. Or is it an inverse variation, in which case my x values would increase and my y values would decrease, but the product of each ordered pair would have the same constant of variation, or k? Or would I end up with neither? If I have a direct or inverse variation, then I want to write an equation to model that direct and inverse variation. Here, on my first example, I have x that has values that are increasing. I have y with values that are decreasing. Therefore, this is possibly inverse variation. Now I need to determine, is k the same for each ordered pair? Or in other words, is the product of each ordered pair the same value? 8 times 1/4 is going to give me 2. 4 times a half is 2. 1 times 2 is 2. And 1/3 times 6 is 2. Therefore, I get the same k value. And I know that since this is increasing, my y decreasing, this is an inverse variation. and my k happens to be 2. And I know my general form is y equals k over x. Therefore, y equals, with k, a constant of variation of 2, is 2 over x. On my next example, I have x values that are increasing, and my y values are increasing. This is possibly a direct variation. I need to determine, is my ratio of each ordered pair y over x the same? Y over x is 12 over 2 is 6, 18 over 3 is 6, 24 over 4 is 6, and 36 over 6 is 6. Therefore, my constant of variation in this direct variation is 6. And I know my general form is y equals kx. And when I substitute in, y equals 6x for my direct variation. On my next example, I have values of x that are increasing and values of y that are decreasing. I need to determine if this is an inverse variation. First of all, x increases and y decreases, so it's possibly an inverse variation. Let's determine if my constant of variation is the same for each ordered pair or product of x, y. Here, 8 times 1 is 8, 4 times 2 is 8, 1 times 8 is 8, and 24 times a third is 8. Therefore, my constant of variation is the same for each. It's k, and I know this is an inverse variation. And my general form is y equals k over x, and my constant of variation is 8. So y equals 8 over x. My next example, I have x values that are increasing and y values that are increasing. So this is possibly a direct variation, but I need to determine, is my k the same for each ratio of y over x in each ordered pair? In other words, 5/3, 7/6, 8/7, and 10/8. And I can see that each ratio is not the same. This would be 1 2/3, 1 1/6, 1 1/7, 1 2/8. Therefore, the k values would not be the same for each. Therefore, this is neither a direct variation or an inverse variation. This slide represents combined variation examples. On my first one, I have z varies jointly with x and y. X and y are going to be directly related to z, but they call it jointly since it would be the product. And it is written as z equals k times x times y. Here, z varies jointly with x and y, again, directly, but since it's going to be a product, they call it jointly, and inversely with w. And here we write z equals k times x times y over w. Here, jointly with x and y, and inversely with w. On this one, z varies directly with x, stated because I don't have a product in the numerator, and inversely with the product of w and y. Z equals k times x over wy, directly with x and inversely with w and y. Let's take a look at some examples. So here, describe the combined variation that is modeled by each formula. I already have that specified to the right of the formula. V equals 1/3 pi r squared h. V varies jointly with r squared and h. F equals mv squared over r. F varies jointly with m and v squared, but inversely with r. P equals m over v. P varies directly with m and inversely with v. And W equals V over LH. W varies directly with V and inversely with the product of L and H. Let's take a look at some examples. Here I want to write the function that models each variation. Find P when Q equals 6 and R equals 10. From this statement I have P varies jointly with Q and R. Therefore, I can write P equals K, Q, R. Now I'm just going to substitute the known values in and solve for the unknown constant of variation. Here I have P equal to 48. I want to find K. They give me Q, which is 2, and R, which is 6. Simplify. 48 equals 12K. Divide by 12. K equals 4. Then I could write this as P times K, Q, R. But now I can substitute in and I'll get the model. P equals 4 QR. Now I have to go back to the original question. I want to find P when Q is 6 and R is 10. Since I've found the model for this function, I can now substitute in the values to find P. I'm given that P equals 4, Q is 6, and R is 10. Then I solve, and P is going to equal 4 times 6 is 24 times 10, 240. On this example, I want to write the function that models each variation. Find P when Q is 6 and R is 10. P varies directly with the square of Q and inversely with R. Therefore, I write the model P equals K directly with Q squared and inversely with R. Now I substitute in the known values. P is 20. I want to find K. Q is 4. Squared, of course. R is 4. Now I want to simplify. 20 equals 16K over 4. But I can simplify that again. 20 equals 4K. And K equals 5. Now I want to write the model. P equals K, Q squared over R. And substitute in my known value of K. And I get P equals 5 Q squared over R. Now I need to go back to answer the original question of the problem, which is I want to find P when Q is 6 and R is 10. Since I found the model for the function, I can now just substitute the values in. P equals 5 Q squared, but Q is 6 squared, over R, which is 10. Simplifying, P equals 5 times 36 over 10. The easiest way to do this, rather than multiplying, is to simplify the fraction. So I can get P equals 36 over 5 and 10 simplified to 1/2, which is just 36 over 2, or P equals 18. In this example, each ordered pair is from an inverse variation. Find the constant of variation. I know to determine the constant of variation, the K in an inverse variation equals the product of X times Y. Well, I'm given an X and a Y in my ordered pair. Therefore, K equals X times Y. K equals 0.4 times 7. K equals 2.8. On my next one, again, an inverse variation, K equals X times Y. Bring down the K, substitute in. I have the square root of 36 times the square root of 4. I could multiply that together and get the square root of 144. Or I could write K equals the square root of 36 is 6 times the square root of 4 is 2. In either case, 6 times 2 is 12, and the square root of 144 is also 12. Each pair of values is from a direct variation. Find the missing value. Well, here I know that the constant of variation is K equals Y over X for a direct variation. So all I need to do is substitute in from my known ordered pair. and find k, then resubstitute in with the unknown value of 6 and y. So here I have k equal to, my y is 2, my x is 3. Now I know my constant of variation is 2/3. So I can rewrite and state k equals y over x. I know my k is 2/3. From my other ordered pair, I don't know y, so that will stay y. And my x is 6. Multiply both sides by 6, I get y equals 12 over 3, or y equals 4. And on my next problem, again, I know that my constant of variation in my direct variation is k equals y over x. Substituting my known values in, k equals 10 over 6. Then I can simplify. 2 goes into both. I get 5/3. Then I can use that into my next ordered pair. K equals y over x. K is 5/3. X is unknown, so it is x. And y is 8. Then I can multiply both sides by x. I get 5/3 x. I could also cross multiply. And then multiply both sides by the reciprocal, which is 3/5. And my solution is 24/5 for the value for x.